Today we will be building a box. Our box has a length of 32 inches and a width of 20 inches. 4 squares have been cut out of our box. Each side of the square is X inches. Our goal is to find the length, the width, the height, the perimeter, the volume, and the area with the corresponding units. Since our length is 32 inches and we have to find the missing pieces, we're going to do 32 minus 2x for the length, and then we're going to do 20 minus 2x for the width. Using those two expressions, we are going to make our polynomial. Our polynomial is going to be x times 32 minus 2x times 20 minus 2x. With this polynomial, we could either put it into the graphing calculator as it is, or we could expand it by using FOIL. And then that gets us 4x cubed minus 104x squared plus 640. Putting it into the graphing calculator, we get the points 4 and 1125. Four represents our x, so we're gonna just fill in x with 4. Now to find our new length, we're gonna substitute 4 for x in our expression. So 32 minus 2 times 4. That gets us 24. So our new length is 24 inches. And to find our new width, we're going to substitute 4 for x again. So our new expression or equation is now 20 minus 2 times 4, which gives us 12. So our new width is 12 inches. Now, since we found our new length and width, which is 24 inches and 12 inches, we can move on. And since now we know what x is, so x equals 4, that means the height of our box is 4 inches. Okay, to find the perimeter, we could either add up all the sides or we could just use this equation. 2 times 24 plus 2 times 12. And then that gets us 72. So our perimeter is 72 inches. Okay, to find the area, we must multiply the length times the width. So A is going to be 24 times 12, which gives us 288 inches squared. Now, to find the volume, we must multiply the length, the width, and the height. So our volume is going to be 24 times 12 times 4. And that gets us 1152 inches cubed. Now, since we know our perimeter, which is 72 inches, and our area, which is 288 inches squared, and our volume is going to be 1152 inches cubed, we are done with part 1 and we can move on to the next part. Okay, for part 2, we must find the volume of these expressions where x is given a different number. Our first equation is going to be 24 times 12 times 1. That gives us 288. And since it's the volume, we're going to do inches cubed. All right, next we're going to do 24 times 12 times 2, which gives us 576 inches cubes. Then 4 times 12 times 3, which gives us 864. So 864 inches cubed. Next, we have 24 times 12 times 3.5, which is 1,008 inches cubed. our next equation is 24 times 12 times 6, which is 1728 inches cubed. And then finally, our last equation is 24 times 12 times 7, which gives us 2016 inches cubed. Oh, cubed. All right, now we're done with part 2. Okay, so for part 3, it says, based on your volume calculations for the different values of x in problem 2, if you were trying to maximize the volume of the box, between what two values of x do you think the maximum will be? Okay, so our x value is greater than 4 because it is our current height, and less than 20 because once it is equal to or greater than 20, you can no longer fold the box in real life. For number 4, we have to determine the side length x of the square that maximizes the volume of the box. To do this, we have to use the expression that we got after we followed our first expression, which is 4x cubed minus 104x squared plus 640x. Now we have to find the derivative of this expression. So dv over dx equals 12x squared minus 208x plus 640x equals 0. Using this formula, we're going to put it into a quadratic. Okay, so now we have to rewrite this to find x. So x equals 208 plus minus square root of 208 squared minus 4 times 12 times 640 divided by 2 times 12. Now this gets us, x is going to be estimated at 9.33. So this is our new x. Now to find the new length, we must go back to our original length, which is 32, and then we must do minus 2 times 9.33, which gets us 13.34 inches. So that is our new length, 34 inches. So this is our new width. Now to find our volume, we're gonna multiply our length, our width, and our height. So 9.33 is representing our height. So our new equation for this is gonna be 13.34 times 1.34 times 9.33, and that gets us 16372 inches cubed. This is our new volume. For my open-ended question, you must determine the diagonal length of the original box. Thank you.